Now we are going to construct some polygons using a straight edge and our compass. All right. I have this point right here. That's all I have on this paper here. I have this point, and I'm going to construct a square inscribed in a circle. So inscribed means that it's just completely contained inside the circle, basically. That's all it really means. So here's how I'm going to do this. First, I'm going to draw a circle. So I'm going to put my pointy end on this point, and then I'm going to draw a circle all the way around. Try not to push too hard on my compass so that it spreads out a little bit. Having problems with that. Now I have a circle. All right, there we go. Now I'm going to find a point on this circle. Anywhere I want. I'm going to put it right here because I feel like I would like my my square to look a certain way. So here's my point. Now what I can do here is I can connect these 2 points, my center point and this point I put out here on the outside of the circle. If I draw a line from one side of the circle to the other side of the circle, I have a diameter. So there's my diameter. Now, I've got this point and this point. If I were to have a point up here at just the right spot and a point down here at just the right spot, I can connect these 4 points and I would have a square. And so that's what I'm going to do. But this point up here and this point down here, they have to be on a segment that is perpendicular bisector of this segment. So we construct a perpendicular bisector here. I've got to open up my compass a little bit. Because it's got to go farther than halfway. Draw an arc, draw another arc, then I draw a line or a line segment that connects these 2 arcs. There it is. Now I have a perpendicular bisector of this segment here. This goes through here. This should be 90 degrees here. And so now I find these points on the outside of, or on the edge of the circle, and I just connect the points on the edge of the circle with one another. Notice I'm doing the points that are on the edge of the circle. None of the other points matter at this time. Once I get these points connected, I now have a perfect square inscribed inside a circle. All right, now here are the steps we took to draw this square inscribed inside of the circle. We put the pointy end on the center point. We drew a circle around and then we drew a diameter through the center point, and I labeled this A and B. And then I constructed a perpendicular bisector of AB and drew that there and labeled those points C and D. And then I drew AC, CB, BD, and DA, and I have now a square. And now here's a little reflection for you to think about. Why does a perpendicular bisector, how can we use that to make the square? How did that work? I don't know. But down here at the bottom, we have a U-try. So again, just do what we just did again there. Draw the circle, draw a diameter. Should I do that one more time? You can just rewind it and do it again. Let's go on to the next part here. We are going to now construct a regular hexagon inscribed inside a circle. Alright, is this open too much? Yeah, it's a little bit too far. Let's close this up a little bit so it fits in that space right there. All right. Hexagon inside of a circle. That sounds fun. First we draw a circle all the way around. Then we pick a point on the circumference of the circle. We just pick a point. Let's do a point right there. Now, we didn't change the compass. That's important. Once we drew this radius, we drew all the way around, don't change the compass. All we do now for this regular hexagon is we put our, we have this point here that we made, we put our pointy end on that point, we draw an arc. Now we draw an arc with our pointy end on the intersection of that arc that we drew and the circle. Then we do another one. Then we do another one from that intersection. Then we do another one from that intersection. And we get all the way around. We should have an arc that goes right through that point. Oh, look at that. Cool. Perfect. Now, once you've done that, you can see, look, 1, 2, 3, 4, 5, 6. We've got 6 points to connect. Boom. A regular hexagon inscribed in a circle. Now let's look at the notes that we would take here in class, if we were in class. So for step 1, we drew a circle from the center point. We pick a point on the circumference somewhere on the edge of the circle. Then we keep the compass setting of the radius. And then we place the pointy end on the point, and we just start drawing arcs from those intersections all the way around. Then we use a straight edge to connect all of those points. And that's it. Now here's your question. In a hexagon, what are each one of these angle measures? Dun dun dun. Look in your notes. Maybe you should have some extra credit if you email me with the answer to what is the angle measure of each one of these. That would be a good idea. It's over 90 degrees. I'll give you a little hint. Alright. Next part of this, and last part I believe, is construct a triangle, an equilateral triangle inscribed in a circle. Alright, an equilateral triangle. Remember, an equilateral triangle means that every side of the triangle, all 3 sides, are the exact same length, and each angle is the same angle measure. And so in equilateral triangle, each angle measure is 60 degrees, because 180 divided by 3 is 60. Alright, so first we are going to draw a circle. Keep your setting of your radius there. I'm going to draw a point on the edge of my circle. That is my starting point, and I'm going to draw an arc, then put my pointy end on the arc intersection, put my pointy end on the arc intersection, draw another arc, keep going all the way around. Wait a second, didn't I just watch this? We just did this, didn't we? We totally did just do this just now. But well, I didn't do it quite as neatly as I did last time. But here's what we do. Don't worry, we're still doing an equilateral triangle here. We just start with an equilateral hexagon. Notice a hexagon has 6 sides. A triangle has 3 sides. And so what we can do here is we can just connect every other intersection point. So we skip one. Let's skip this one here too, every other point, and then connect these 2 guys here. and we have an equilateral triangle. Boom. There it is. Not so bad. Let's look at the steps that we took to complete this. So step 1, same as a hexagon. We just did the same steps. Drew our circle, picked a point, kept our radius, went all the way around. Step 2, same as hexagon. So we skipped that step just now, but you connect all of those points. And then step 3 is you connect every other point until you get your triangle. And that's it. That's how you do it. Now it's time to do all of these U-try things down here. Nice work.